Hi, I am SB sir, and today I'll teach you the basics of respiration. Whatever was there in my earlier class, I'll just quickly summarize and I'll start the other basics of respiration here. So this picture tells about our ribs. We have a drawing here. See this picture. So our ribs are arranged in such a way that it's there in the thoracic chest cavity. Up to here it is the thoracic cavity, because here you find the diaphragm. So I'll just draw this picture a little bit to let you know. So if this is the sternum and the ribs are attached here, the ribs are attached to the sternum, as you see here. So there are certain ribs which are not attached to the sternum. The sternum ends here, and there are ribs which goes these ribs which comes from the back, the lower ribs which comes by the back and don't find this sternum here, and these ribs are called floating ribs. So these are the ribs which goes on to join the vertebral column, but these ribs which come from the vertebral column, from the backward vertebral columns, are here floating. Between the ribs, we know, as you see here, there are muscles, and these are the muscles which are between the ribs. So there are muscles between the ribs, and so there are two types of muscles: the internal intercostal muscles. So as these muscles are between the ribs, we call these muscles as intercostal muscles. So there are two types: internal intercostal muscles, and external intercostal muscles. So as you find that there is a difference in arrangement in this two, as the name suggests, something is different in internal as well as external intercostal muscles. So that we have to know. So for that, I'll draw a certain picture and let you know about that thing. Suppose there are two ribs. I draw two ribs. One rib, this is rib 1, this is rib 1, and a lower rib, rib 2. So how these muscles are placed is actually different. So these muscles are placed obliquely. So in case of the external intercostal muscles, these muscles comes from the backward of the upper rib and joins the frontal portion of the other rib. So here the muscles are joined, and I'll draw, as I don't see it from this view, I'll give some dotted lines here. So these muscles are from the upper rib, they come from the backward and join here in the frontward portion. And if these are the external intercostal muscles. So why is this arrangement? So this rib, as we know, that the ribs are in a particular orientation. How? Say these are the two ribs. If you see my hands, these are the two ribs in this particular horizontal plane. The lower ribs is actually below. The lower ribs are actually below and a little backward. So while these external intercostal muscles contract, the lower ribs comes to the front. The lower ribs comes to the front and upward. The muscles contract like this. It pulls the lower rib upward and forward. Means it pulls. So if we see this is the distal part of the body, and this is the frontal. So this diameter of the chest cavity is increased. The diameter of the chest cavity is increased because the lower ribs comes forward and upward. So by the contraction of the external intercostal muscles, the ribs come forward and upward, the lower ribs. So the chest cavity, there is an expansion of chest cavity. The chest cavity comes upward. The chest cavity comes upward because of this contraction of this external intercostal muscles. And while the internal intercostal muscles contract, the chest cavity goes down to its original position. So we see while the chest cavity increases in size, increases in diameter, if it comes forward as well as upward, so it increases in diameter, it is expanding because of the contraction of the external intercostal muscles. And because of this contraction of the external intercostal muscles, because of the contraction of this external intercostal muscles, there is a volume increase of the lungs, the volume increase of the thoracic cavity. I'll reserve my word for lungs because there is an increase in the thorax. The thoracic cavity is very much closely opposed, like two glass slides. If I draw two glass slides, and put a drop of water here, and then I put the slide on this, so the water will form a film, but then you will not be able to separate out these two glass sides. You will not be able. Why you will not be able? Because the water has a surface tension. It has increased its surface because the glass slides have now posed to one another, and it has increased its surface, and this surface tension is now hugely increased. The drop has spread, and because of the surface tension, the slides will not go apart. This happens in our thoracic cage also. Because the thoracic cage expands, and we know that, say I draw this thoracic cage wall here where the ribs are present. I'll draw the cross section of the ribs here and the lungs here. Say this is the right lung, and this is the part of the body. I draw the hands. So this is the thoracic cage, the wall of the thoracic cage, the wall of the thoracic cage, the wall of the lung. The internal wall of the thoracic cage has a membrane, and this membrane is called external pleural membrane. And the internal part of the lung also has a membrane, and this membrane is also called a pleural membrane. The internal lung has a pleural membrane, and this is called internal pleura. So between this there is water. Here you find water here. Water. So just like these two glass slides where the water has spread and it has increased its surface to increase the surface tensions, so there is water here, and this also happens in between the two pleuras. So between the two pleuras, the space is called intrapleural space. Intrapleural space. And you have the lung here. This is the lung. This is the lung, and this is the thoracic cage. This is the thoracic cage. On above you have the skin, and you show it externally. So this is the thoracic wall. So these are the three spaces. One space is this. This is, say, space 1. This is another space. This is another space. I'll draw it. This is intrapleural space. This is the intrapleural space. So these two spaces, the space 1 and space 2, are very much linked to one another. So if the thoracic cage expands, it will pull up the lungs also. And what it will do, it will forcefully expand the lungs. The lungs tries to get shrinked. It has always a tendency to get shrinked, to get shrinked in a small volume. That is the elastic recoil of the lung. The elastic tissues of the lung in the book you will find this word very often, that elastic recoil of the lung. Why is it elastic recoil of the lung written? Because the lung tries to recoil while the chest wall tries to expand. The nature of the chest wall, the properties, the elastic properties of the chest wall is such that it tries to expand. So it goes this way towards expanding, and the lung tries to recoil. So there is always a negative pressure between these two slides. You pull the slides apart, so there is a negative pressure here in between the two slides where the water is there, and likewise here also in between the interpleural space there is a negative pressure build up. And because there is a negative pressure build up, the lung wall or the internal interpleural wall always stays very opposed to each other, and there is this because of this negative pressure. This is one of the chambers of our body. This is one of the spaces in our body, this intrapleural space, where there is a negative pressure. Always there is a negative pressure. And because due to this negative pressure, the wall of the lung, the internal pleura, the red line always stays opposed to the external pleura. And because of this negative pressure, there is a suction kind of pressure always there. There's suction kind of pressure. So the pleural spaces are having a negative pressure, and due to that the lung wall always stays attached to the thoracic wall. And if we increase the thoracic wall, if we increase the thoracic volume, the lung also, in spite of its recoil, is forced to increase its volume. So the chest wall actually aids the lung to increase its volume. The lung tries to shrink like a balloon. It's like an elastic balloon which always tries to get smaller, but the chest wall will always, through its suction pressure, will always try, because the chest wall always tries to expand because of its elastic properties, because of the ribs, because of the muscles. It has an intrinsic elastic property, and that elastic property is towards expansion of the chest wall. The chest wall always tries to go outward and forward and increase the thoracic chest volume, while the lungs always tries to get shrinked. And due to this opposing forces, the intrapleural space is always having a negative pressure. The intrapleural space is always having a negative pressure, and so the lung stays expanded. Now I'll go a little bit to the mechanics of respiration. The mechanics of respiration will primarily, while I teach you the mechanics of respiration, I'll have to tell you about first primarily the muscles of respiration, how the muscles will pull up the thoracic wall, how the diameters are increased. So I'll go to that. First I'll draw you something. So if this is the lung, say this is the lung and the airways that supplies the lung. The airways that supplies the lung. So we have the right lung and the left lung drawn here. So these two lungs actually occupy a certain volume, and this volume is increased by the contraction of the thoracic wall, the contraction of the thoracic wall, the contraction of the muscles of respiration, precisely the contraction of the, remember, external intercostal muscles. The contraction of the external intercostal muscles will pull the ribs forward, and there is an expansion of the volume. Now, if we see, if we observe a body, if you say observe this human body, it has different axes. So this is the anterior most head, here is the leg, so this is the posterior portion. These are the lateral sides, and this is the ventral side of the body, and the back is the dorsal side of the body. So there is a dorsoventral axis, anterior posterior axis. This is the anterior part of the lung. This is the posterior part of the lung. There is a axis from this is the inside of the body, and that is the back of our body. So that is also an axis. then that axis is called dorsoventral axis. So the backward dorsal part, dorsal body surface, and the ventral body surface. So this is the anteroposterior axis. And I just told you that there is a very important, muscles of respiration apart from these external intercostal muscles are diaphragm. Diaphragm. So I draw the diaphragm here. Why I draw the diaphragm in such a gross way? Because here there is a dotted line here showing the diaphragm. To signify that, I just put a very bold black line here. It's like a dome. So when this diaphragm contracts, the dome is flattened. The dome is flattened. So while the dome gets flattened, there is an expansion. See, if I take this as chest, our body, and I draw the hands here. So this is the thoracic cage where the respiration thing is happening. This volume is now expanded because of the flattening of the diaphragm. The volume here has expanded. Initially it was less. It was here. It was less. Now it has expanded. The diaphragm has come to the posterior axis of our body. It has come down. The dome has flattened, and due to that, what happens is there is an anteroposterior axis. The anteroposterior axis of our body gets enlarged, and the volume gets enlarged. The thoracic volume gets enlarged. Now this was not the part of the volume. This was not the part of the volume. Now this volume, because of the flattening of the diaphragm, we get this more. We get this volume more. There are other muscles also apart from external intercostal muscles. So external intercostal muscles, then diaphragm, we have now known the importance of the diaphragm, and the third important muscles of respiration are the abdominal muscles. So when this diaphragm comes below the abdominal contents, here you have the liver, stomach, intestines, pancreas. These abdominal contents gets outward. The abdominal muscles get relaxed, and abdominal contents go outward. The diaphragm pulls down, the abdominal contents gets outward, the abdominal contents get outward, and so the relaxation of this abdominal content actually increases the thoracic volume. So the diaphragm pushes, when the diaphragm pushes to the below, to this below side, the abdominal contents, the abdominal muscles relax, the abdominal contents go outward, and you see a protruding of the belly. The belly protrudes out, and so the thoracic volume increases. So there are the abdominal muscles, which also helps in respiration, which also helps in increasing the volume of the thorax. So I'll rub this out, and I'll go to this picture. This picture is from Sherwood, a book called Sherwood, where illustrations like this are given, and you see this picture here now. So the external intercostal muscles are drawn here. So these external intercostal muscles and diaphragm are the major muscles of inspiration. Why? Because these muscles contract, the external intercostal muscles contract to pull the lower ribs outward, to pull the lower ribs. The lower ribs are also lower as well as they are inside the body. So these loops, when pulled outward, when these ribs are pulled outward, they increase the volume of the thoracic cage. So this external contraction of these external intercostal muscles and the contraction of the diaphragm goes below. These are the major muscles of inspiration. They contract with every inspiration. Relaxation causes passive expiration. So I will just explain this point. Relaxation causes passive expiration. Relaxation causes passive expiration. So when these ribs are not pulled down, the lower ribs are pulled up. So the volume is increased. So they relaxes. So the volume gets again to the original position. The diaphragm relaxes. The diaphragm was now, when the muscles of the diaphragm were contracting, the diaphragm got flat. And now when the diaphragm relaxes, it again goes up. The abdomen goes, the protruding belly goes inside the body. The protruding belly gets inside the body. The diaphragm again relaxes and assumes this dome shape. And the external intercostal muscles, which were pulling the lower ribs upward, all the lower ribs upward, are now relaxed. So the lower ribs has come to their original position. So there is a contraction of the volume, the ribs getting downward, the diaphragm getting upward, and the abdominal muscles pulling the belly inside. So there is a buildup of pressure here in the thoracic cage. The volume is now shrinked, and there is a buildup of pressure, and so the air automatically goes out. The air goes out during expiration because of this pressure buildup. So what was there during inspiration? I'll just quickly revise. During inspiration, what we do is actually we increase the volume. And when the volume increases, from Boyle's law and Charles' law, we know when the volume increases, PV equal to constant. When the volume increases, the pressure automatically decreases. With the same air volume, when we have the same air, and this air is now, the volume has increased, the thoracic cage has expanded. The thoracic cage has expanded because of the contraction of the external intercostal muscles, the lowering of the diaphragm, the pulling outward of the abdominal muscles. The thoracic cage has expanded. The volume has increased. So there are lesser molecules of air, lesser molecules of pulmonary air occupying a same volume, or that means lesser molecules occupying the same volume means pressure has decreased. Pressure inside the intrathoracic cage has decreased. Pressure in the lung air has decreased. So when the pressure has decreased, what happens? Air automatically gets sucked in the trachea and goes into the lung. There is a suction of air pressure and it goes into the lung. As this volume has increased, the pressure has decreased, so the air goes inside. So this is all about inspiration. Why inspiration occurs? Because there is a lowering of pressure. Why expiration occurs? Because there is a buildup of pressure. More pressure inside the lung, all the shrinkage of volume, the shrinkage of volume of the thoracic cage has resulted in the pressure buildup. So air goes out, just like a balloon which will try to contract inside. It will, if the mouth is open, it will push up the air, it will evacuate. Just like that, when the thoracic cages are now putting pressure, the diaphragm getting inverted, the volume is getting low, the volume is getting compressed, so pressure is building up and the air goes out just by the relaxation of these muscles. So relaxation caused passive expiration. That at this point we have now known. We now know this point that relaxation actually causes passive expiration. And what are the muscles of active expiration? Now I'll come to this point. What are the muscles of active respiration? This is passive expiration. Passive expiration means just you relax these muscles, the air will go out. But when you try to breathe very sharply and breathe out very sharply, breathe out fast, so that is active expiration. I try to breathe out more air. I try to breathe out fast. So I'll actively expire like this. And this happens with the contraction of the another muscle called internal intercostal muscles. These internal intercostal muscles are also placed obliquely. These are also placed obliquely, but just the reverse. As the external intercostal muscles in the upper ribs are inside and the lower ribs are outside, here in case of the internal intercostal muscles, the upper ribs will have those in the internal muscles. The upper ribs will have the muscles exterior, and the lower ribs will have the muscles interior to the body. So contraction of them, this internal, if this internal intercostal muscles now contract, it will forcefully make the thoracic cage come down. It will forcefully make the thoracic cage come down. It will forcefully lower the upper ribs. It will forcefully lower the upper ribs to come to the lower ribs. The upper ribs are now approaching the lower ribs, the position of the lower ribs. So the thoracic cage is getting depressed very sharply, and so there is a pressure buildup and the air goes out violently. The air goes out with a huge amount of pressure, so you can actually blow out air during active expiration. So I'll just revise this whole diagram. This diagram tells you about sternum, ribs, external intercostal muscles that you know by now, diaphragm, the major muscles of inspiration. The major muscles of inspiration are the external intercostal muscles and the diaphragm. The muscles of and the major muscles of inspiration. Inspiration is taking up air. The major muscles of inspiration, external intercostal muscles and diaphragm, whereas expiration is actually passive. It is just the relaxation. The contracted muscles will no longer be contracted. It will relax, and the lung volume will get shrinked, and just due to this shrinkage of this lung volume, the pressure build up and the air will go out. And here they have shown these abdominal muscles, the abs that we tell, the muscles that are visible on the belly, on the upper part of the belly as well as in the lower part of the belly, the brands that are present. These are the abdominal muscles. These muscles relax while we inspire and the belly goes out, and these muscles contract. The abdomen goes flat. The abdomen goes flat and these muscles contract, and so our thoracic cage volume is pushed up. The thoracic cage is pushed up, the volume gets lowered, and there is a pressure buildup in the thoracic cage, and the air goes out. So that happens during active expiration. Contraction, the muscles of active expiration are the internal intercostal muscles. The internal intercostal muscles, the muscles of active expiration, contract only during active expiration. And there are the accessory muscles of inspiration. These muscles contract forcefully while we will be taking forceful inspiration. These are the sternocleidomastoid, sterno, cleido, mastoid muscles, and the scalenus muscles, scalenus muscle. Scalenus muscle and the sternocleidomastoid muscles, these muscles are present in the neck, and these pull up and they increase the thoracic volume. These muscles pull up, and these muscles these are the accessory muscles of inspiration, and they only contract during a forceful when you try to put more air inside the lung, forceful inspiration. When you try to, if you remember my earlier class, I have told you about the volumes, and when you try to grab in more air, when you try to suck in more air, that is when these accessory muscles of inspiration come into action. Now, I have already drawn this thing. Here you see, this is a curve of spirometry, and you see this is the tidal volume. This is the tidal volume. Why does the tidal volume? It is while we are at rest, we always consume oxygen. We always has to consume oxygen. So there is always respiration, whether we are conscious or not. We always respire, and we respire by taking this tidal volume, this amount of air, this is 500 ml of air, and this 500 ml of air is called the tidal volume, and we draw a wave, of tidal volume, and this volume, there is a when the lung shrinks, you put up this air, and the volume goes down, but the volume goes down up to here. This is a resting lung volume. This is a kind of resting lung volume, and this volume, this level of resting lung volume is called functional residual capacity. Why is it called functional residual capacity? That I'll explain. So the lung has the ability to contract from here to here. That is the primary point, and after you know that this, only I can go into details about this is the whole volume. So this is 0, this is around 1, this is 2, this is 3, this is 4 liters, this is 5 liters, and they say this is 6 liters mark. So the whole lung, this total volume is called TLC, total lung capacity. So this is around, say, 6 liters. And you know by my earlier class that this volume, the volume that is exchangeable, the volume that you can take in and take out after a forced inspiration and a forced expiration after that, by taking whatever amount of air you can take and maximally expanding the lung, you reach up to here, and then you reach here, you have fully expanded your lung, this amount of air, you have fully expanded your lung, and then you are trying to exhale very heavily. A very active expiration goes, and you will now go down to here. So there are different levels of going down. So at rest, while we are at rest, we are going down up to here. But during a heavy expiration, we can go down up to here. So this level is one volume. This is called residual capacity, functional residual capacity. This is another volume. Still there is some air left in the lung. You maximally go out, you maximally breathe out here. Still there is some volume in the lung. That is present as the total lung capacity. This is from here to here is the total lung capacity. And the exchangeable air from here to here is the vital capacity. From here to here is the vital capacity, VC, vital capacity. Now, what is this? This is residual. You cannot exhale this amount of air. So this is residual volume. Residual volume. This is around, say, 1.2 liters. 1.2 liters. And what is this volume? This is around, this functional residual capacity is just double this volume, 2.4 liters. So this is another 1.2 liters. This is the expiratory reserve volume. Why is it the expiratory reserve volume? So with this expiration, with this small amount of expiration that we take in the air, that we take in at rest, and breathe out, take in, breathe out, take in, breathe out, take in, breathe out, take in, breathe out. So this small volume was only 500 ml. So we are taking in 500 ml, breathing out 500 ml. And there is a gaseous exchange that is taking place. Oxygen is, while we breathe in atmospheric air, oxygen is coming inside our body, and we are throwing out carbon dioxide into the lung air, and that lung air is going out. But the volumes remains the same. 500 ml of air goes in and 500 ml of air goes out. But there is a compositional change in the air. Now I want to tell you about this expiratory reserve volume. For that I have made too much introduction about this. So while we breathe out this much air, we have the capacity to breathe out this liter also, this 1.2 liters also, but we never breathed out that thing. While we forcefully expire, we only expire this volume. This volume goes down only during a forceful expiration process. So this is called expiratory reserve volume. You always have this reserve volume. If you want, we can expire out this air from this level. So this is why this is called functional residual capacity. This level, from this level to this level, from this level to this level, this is called functional residual capacity, and this is called residual capacity, because this is the air which is permanently an inhabitant of the lung, which is a permanent inhabitant of the lung. Because we generally at rest, we just breathe out, breathe out, breathe in, breathe out, breathe in, breathe out, and this amount of air, 2.4 liters of the air, remains as a functional air. From this air, you can still absorb oxygen. You can still liberate carbon dioxide from this air. So it is a functionally exchangeable volume, where oxygen from where oxygen are taken in throughout. Either it's over above the inspiration and expiration going on. But this amount of air is constant, and this amount of air, whatever oxygen it has, if the body has an availability of this oxygen. The body has an availability of this oxygen, and body can deliver carbon dioxide into this volume also. So this is called functional residual volume, and this volume is 2.4 liters. This volume is 2.4 liters. 1.2 liters for the residual volume, which you cannot throw out. The lung, the mandatory air that has to be there in the lung, the mandatory air that has to stay in the lung, it is 1.2 liter. Another 1.2 liter of expiratory reserve volume makes this total volume of FRC 2.4 liters. So now 2.4 liters plus this 0.5 liters goes to around 3 liters. Another 0.5 liters of tidal volume. So this is 3 liters. 2.4 liters plus 500 ml, it becomes 3 liters, and this volume is left now. So deducting from the 6 liters of total volume, so another 3 to 3.5 liters are left, which is the inspiratory reserve volume. Inspiratory reserve volume. Inspiratory reserve volume. That means if we want at any point of time, if we want to prolong our inspiration, if we want to take in more air than what we have actually taken in, we can breathe in from this point to this point, and we can go up from this point to this point, go up from this point to this point, and breathe in another 3 liters of air, breathe in another 3 liters of air. And this, we don't do it while we are at rest, but while we exercise or we do a certain level of highly intense work, we need this volume, and then we actually take in much more air, and we take in this inspiratory reserve volume. It's not mandatory that you continually take in this 3 liters, and it can be such that you can take in this much of, if your respiration is like this. It can be like this. It can be like this. So by this and this is increase in depth of respiration. I have used up a certain volume of inspiratory reserve volume, certain volume of expiratory reserve volume. This is also a increase of depth of respiration. The depth of respiration, the volume has increased. I have used up more relative to this. I have used up much greater fractions of this inspiratory reserve volume. Greater fraction of inspiratory reserve volume and a lower fraction of expiratory reserve volume. Relative to the inspiratory reserve volume has been used up much more. So this can take place, and it depends on subject to subject, on person to person. There is a variation of how you utilize while we breathe heavily, and and the highest breathing effort, with the highest breathing effort, you can breathe in only this the total vital capacity, and this is the highest breathing effort. This is the highest exchangeable. But we can use this total while breathing heavily. You can use a fraction of this total volume, and this fraction may be here. This fraction may, say this is the increased fraction. This was the lower fraction, this was the tidal volume. I increase this fraction, but this fraction can be here, this fraction can be here, this fraction can be here, up to here, this fraction can be here. So actually, what is the difference when the fractions go different in different persons? Actually, when you are coming down to a certain level, the FRC line, this FRC line is getting here. This FRC line is getting here. Say the FRC line is here. Say the FRC line is here. So you are breathing heavily here, and your FRC line is here. So the resting lung volume while you are breathing heavily is now this. Maybe this will be around 0, 1, 2, 3, 4 liters of resting lung volume. This happens in asthmatic patients. The asthmatic patients, they who have obstructions in the airways, actually breathes at a much more higher resting lung volume. Their thoracic cage becomes largely increased. Patients, a person with lung disorders, lung diseases, like emphysema, where the lung gets destroyed, the lung tissues get destroyed, the lung tissues were torn out, they are damaged, the elastic recoil of the lung, the elastic recoil of the lung is no longer present, their rib cages go outward. The rib cages go outward. They can still breathe heavily, but with an outwardly placed increased thoracic volume. Their ribs will be greater in size, their chest cavity will be greater in size, and they will be breathing heavily in this fraction. So this was about the details of this curve that I have drawn here, that I have explained here, is actually result of spirometry. Spirometry. What is spirometry? Spirometry, I'll draw a little figure here out here. While I remove this board, I'll draw a figure to let you know about spirometry. What is spirometry? So I'll take out this board and now go to spirometry. See, I have drawn a wave. Where from this wave is coming? Where from this wave is coming? I have drawn the tidal respiration. Where from this wave is coming? This wave is actually drawn by a stylus. Say this is a stylus, and this is marking this wave. Marking this wave. How this is marking the wave? Because someone is breathing in and out, and this is being recorded by a machine which is called a manual spirometer. A manual spirometer. Someone is breathing, which is getting recorded here. Then what is the arrangement of this? What is this arrangement? Someone has taken a grasp of air, so the volume increases. He breathes in very fast. The rate has increased. Sharp. He takes in more air. The depth has increased. So how this pen goes up and down, the arrangement. I'll draw you the arrangement now. The spirometry arrangement. So I'll place 2 glasses of water. I'll place an inverted drum on this 2 glasses of water. An inverted drum and this 2 glasses of water. So this is the drum. Now I seal the mouth of this drum. Seal the mouth of this drum. The mouth is now sealed. Now I make a little hole out here. and I put a tube inside this hole. The tube comes out, so this is a tube. And now what I do is that I attach a pipe to this tube, and tell someone that you breathe in and out. So here I draw a person's mouth here. So he sucks in air from this drum. So when the air is sucked in, the drum will go below. The air is no longer there. The air is sucked in because this is sealed by water. The drum is sealed by water. Air cannot come through this portion. So the drum, this amount of air, when goes inside the mouth, the drum will go inside. And from this drum, I have put a weight here. This is the stand on which stand on which the drum is resting. Say this is the stand. This drum is resting on this stand. I have drawn a wire, and this has balanced this weight of the drum. So this is the arrangement. So and I put this pen here. I draw a pen here. Pen here. So when this drum goes below, when the air is sucked in, what happens is that this weight is going upward. The drum going below, the weight going upward, and the pen going upward. So there is an inflection of the line. There is an inflection of the line on a kymograph. So this is a kymograph machine where you have a paper roll down here in the machine, and you have smoked the machine with carbon. So the pen will inflict it will remove the soot of this carbon, and it will draw a line. When air is sucked in, this weight will go out. This weight will be pulled up, and you will inflict a line here on this drum. So this drum moves on a machine. Say this is the machine of the kymograph, and this revolves. This drum revolves like this, and with these inflections, the line when the drum goes below, the weight is pulled upward. When you expire, the drum goes above. The air is put inside. The drum goes above. The volume is increased, and as the volume is increased, the drum goes above the water. And when the drum goes above the water, when this drum goes above the water, this one is going down. So it is expiring. The line is going down. The weight is going down, because here you have the fulcrum here. So this weight is when you were expiring, when you were inspiring from this drum, the drum goes below, the line is up. When you are expiring, the drum is going up, and the line is getting down. Here you're getting the down line. So this is the basic arrangement of manual spirometer. A manual spirometer, from where you get these curves of respiration. Thank you.